Imagine opening your laptop one morning and noticing that something feels wrong. Applications take longer to respond. The fans become louder during ordinary tasks. Battery percentage begins falling faster than usual. The laptop feels warmer, even though you're not gaming, editing video, or running a demanding program. You open Task Manager. Nothing appears obviously broken. There's no single application consuming all your processing power. There is no dramatic error message explaining what happened. The computer still starts. Windows still loads. Your files remain available, but the machine no longer behaves like the machine you were using one day earlier. Then, you remember what happened the previous night. Windows installed an update. On July 14, 2026, Microsoft released KB 5.1.1.6.5 for Windows 11 versions 24H2 and 25H2. It was the normal monthly security update, the type of cumulative package millions of Windows computers are expected to receive automatically. The update included important security protections and several reliability improvements. It expanded the deployment of new secure boot certificates. It fixed an issue affecting some third-party applications that used OLE automation to communicate with Microsoft Office. It also changed how Windows cleaned up certain registered keyboard shortcuts. For most users, the update installed and Windows continued working normally. But on a limited number of computers, something unexpected happened. Microsoft discovered that devices using certain Intel Innovation Platform Framework drivers could experience changes in performance, power consumption, or general system behavior after recent Windows updates. The wording was careful. Microsoft did not say every Intel laptop would slow down. It did not say every Dell computer was defective. It did not announce that Windows 11 was completely broken. But the company considered the problem serious enough to stop some affected devices from receiving the July security update. And only 4 days later, Microsoft released another update, KB 5.1.2.1.7.6.7, an out-of-band emergency fix issued outside the company's normal monthly schedule. That is the moment the story becomes important. Microsoft releases Windows updates constantly. Most fixes arrive on predictable dates. Security patches usually arrive during Patch Tuesday. Optional previews arrive later in the month. Large feature changes are tested through Windows Insider channels before reaching ordinary computers. An out-of-band update is different. It means Microsoft has identified a problem that should not wait until the next scheduled release. The company must rebuild the package, test it, publish it, and distribute it while users are already running the update that created the problem. In this case, the emergency patch applied to Windows 11 24H2 and 25H2. It raised the operating system builds to 26100 or 8894 and 26200 or 8894. The patch included everything from the earlier cumulative update, but added a targeted correction for the Intel driver compatibility problem. Microsoft said the update was recommended only for devices affected by the issue. That detail is essential. This was not a worldwide Windows collapse, but it exposed a much larger problem with modern Windows updates. Microsoft is no longer updating one simple operating system running on a small number of predictable computers. It is updating an enormous ecosystem of processors, firmware, graphics drivers, power management systems, security tools, gaming software, business applications, and manufacturer-specific utilities. A change that works perfectly on one machine can produce unexpected behavior on another computer that appears nearly identical. Two laptops may both run Windows 11. They may both use Intel processors. They may even carry the same manufacturer's logo. But underneath the surface, they can contain different firmware revisions, thermal profiles, driver versions, battery controllers, and manufacturer customizations. That complexity is why a security update can suddenly affect battery life. It is why a fix for one Windows component can change how a laptop distributes power. And it is why Microsoft sometimes discovers the real consequences only after an update reaches the public. The July update did not simply fail to install. That would have been easier to understand. Instead, it appears to have interfered with the layer responsible for balancing performance, power, and heat on certain computers. The machine could continue functioning while making the wrong decisions. A laptop designed to remain quiet might increase its fan speed. A processor expected to boost during an application launch might respond differently. A system designed to reduce power consumption during light work might consume more energy than expected. The failure was subtle. And subtle failures can be more frustrating than dramatic ones. When Windows crashes, the user knows something is broken. When the battery quietly loses an extra hour of runtime, the user may blame the battery. When performance falls slightly, the user may blame the processor. When the fans become louder, the user may assume dust is blocking the cooling system. The update disappears into the background while the owner begins troubleshooting the wrong component. That is what makes this type of Windows failure dangerous. It does not always announce itself. Sometimes it simply changes the personality of the computer. To understand why the update produced such unusual symptoms, we need to examine the Intel Innovation Platform Framework. Most computer users think performance is controlled by a simple choice. The processor is either fast or slow. The laptop is either plugged in or running on battery. The power mode is either balanced, efficient, or high performance. Modern laptops are far more complicated. The thin computer has limited space for cooling. Its processor may be capable of consuming significantly more power than the cooling system can handle continuously. The manufacturer therefore creates rules defining how the machine should behave under different conditions. How much power can the processor use? How long can it remain at maximum speed? Should the system prioritize the CPU or integrated graphics? When should the fan increase its speed? What should happen when the laptop is placed on a soft surface? How aggressively should performance be reduced when the battery becomes low? What temperature is acceptable near the keyboard? Should a video call receive different resources than a game? Intel's dynamic tuning. Technology is designed to optimize performance, power, acoustics, and thermal behavior in real time. It monitors workloads, temperature, and power conditions, then helps distribute resources across the processor, graphics, and other platform components. The Innovation Platform Framework is part of the software and driver environment through which these decisions can be implemented. This means the driver is not an ordinary accessory. It sits close to the system's performance management logic. When Windows and that driver communicate correctly, the process is invisible. The laptop becomes fast when speed is required. It becomes efficient when the workload is light. The fans react before temperature becomes dangerous. The user simply experiences a machine that appears to understand what is happening. But when the relationship breaks, several symptoms can emerge from one underlying problem. Performance may fall because the system applies an incorrect power limit. Battery usage may increase because the processor does not enter the expected low power state. Fans may become louder because the thermal management system reacts differently. The machine may feel inconsistent because the problem appears only under particular workloads. Microsoft's official description remained broad. It said the issue could cause changes in performance, power consumption, or system behavior. The company did not publicly describe every symptom, every driver version, or every affected computer model. It confirmed only that a limited number of devices were affected, and that some Dell systems had temporarily been prevented from receiving the July update. That silence creates an information gap. Users experiencing a slow laptop may search online and find dozens of unrelated complaints. Someone blames the graphics driver. Someone blames antivirus software. Someone disables a power management service. Someone changes the Windows power plan. Someone edits the registry. Someone removes the Intel driver completely. A temporary improvement may convince the user that the experiment worked, even if it creates a different problem later. This is where online troubleshooting can become more dangerous than the original bug. The Intel framework exists because laptop manufacturers have designed specific thermal and power limits for their hardware. Disabling parts of that system can change how the computer manages temperature and performance. A workaround that appears successful on one model may be inappropriate on another. The safest solution is usually not to remove random services. It is to install the corrected Windows update and ensure that the manufacturer's approved drivers and firmware are current. The emergency patch also reveals how deeply Windows depends on hardware manufacturers. Microsoft develops the operating system. Intel develops processor technologies and driver frameworks. Dell, Lenovo, HP, Asus, and other manufacturers design the laptop around those components. Each manufacturer may configure performance and cooling differently. A problem can therefore exist between products created by several companies. Windows may trigger it. An Intel driver may participate in it. A manufacturer's specific configuration may determine whether it appears. The user sees only one computer. Behind that computer is an entire chain of companies. When the chain works, nobody notices. When it fails, each company may initially possess only part of the answer. Microsoft may know that crashes or performance reports increased after an update. Intel may know how a driver responds to a particular operating system change. Dell may know which models use the affected combination of firmware and drivers. The solution requires those pieces to be connected. This is why Microsoft uses safeguard holds. When the company identifies a compatibility problem, it can temporarily prevent the update from being offered to devices likely to be affected. The goal is to stop the damage from spreading while engineers investigate. That does not mean Windows Update has failed completely. In one sense, the safeguard is Windows Update working as intended. The problem is that the safeguard may arrive after some computers have already installed the update. Early recipients become the real-world test group. Their devices generate diagnostic information. Support reports begin appearing. Manufacturers identify common hardware. Microsoft traces the pattern. Then the rollout is adjusted. For users, this creates an uncomfortable reality. The same automatic update system designed to protect the computer can occasionally expose it to a compatibility problem before the protection mechanism catches up. The obvious question is simple. Why did Microsoft release the update without discovering the problem? The frustrating answer is that no laboratory can reproduce every Windows computer currently operating around the world. Windows 11 runs on machines from countless manufacturers. Some use processors released this year, others use hardware several generations old. Some systems have the latest BIOS, others have never received a firmware update. Some users installed drivers directly from Intel. Others use manufacturer-customized drivers. Businesses may run security software that ordinary consumers never encounter. Gamers install monitoring tools, RGB controllers, overclocking utilities, and anti-cheat systems. Laptop manufacturers create unique performance profiles for different product lines. Windows must continue interacting with all of them. Microsoft uses automated testing, internal hardware labs, telemetry, preview channels, and manufacturer partnerships. But every additional configuration creates another possible interaction. Imagine testing only 10 versions of 10 components. That already creates an enormous number of possible combinations. Now replace 10 with thousands. A Windows update can modify a shared component used by dozens of drivers. The driver may behave correctly during ordinary testing, but fail when combined with a particular firmware version. The issue may appear only when the laptop changes from battery to charger power. It may occur only after sleep. It may require a specific temperature or workload. It may affect performance without producing a crash log. The computer remains operational, which makes the problem harder to detect automatically. This is why Windows updates are cumulative. Instead of requiring users to install a long chain of older patches, each cumulative update contains the previous fixes needed to bring a device current. The advantage is simplicity. The disadvantage is size and complexity. A monthly update may contain security changes, reliability corrections, and improvements from earlier preview updates. When something goes wrong, users often describe the entire package as one update, even though many separate changes arrive together. KB5.1650 was not only a performance update. It included July's security protections. It contained fixes previously tested through June's update cycle. It expanded secure boot certificate targeting. It addressed third-party Office application failures. It modified hotkey cleanup behavior. Most of those changes were unrelated to the Intel IPF issue, but because they were delivered together, Microsoft could not simply tell every user to avoid the security update permanently. Leaving the update uninstalled would also leave security vulnerabilities unpatched. That creates a race. Microsoft must protect users from attackers without leaving affected computers trapped with a compatibility bug. The out-of-band patch solves that problem by producing a new cumulative package. Users receive the security fixes and the compatibility correction together. This is why KB5.122.176.7 replaced the earlier build instead of functioning like a tiny independent program. For affected users, the emergency update is the correct destination. For unaffected users, Microsoft said it was not specifically necessary unless Windows offered it under the appropriate update settings. This distinction is important because the internet encourages everyone to install every new patch manually. The phrase emergency update creates urgency. People search the Microsoft Update catalog. They download packages intended for different system versions. They force installation before Windows Update determines whether the device needs it. But more intervention is not always safer. If Microsoft says a patch is recommended only for affected systems, ordinary users should generally allow Windows Update and the manufacturer's support tools to manage the process. The July incident also raises a wider question about Microsoft's update strategy. Windows increasingly behaves like a service rather than a product that remains unchanged for years. Security improvements arrive continuously. Features can be enabled gradually. Some changes exist in the operating system before Microsoft activates them. Drivers arrive through Windows Update. Firmware can also be distributed automatically. This keeps computers protected and allows problems to be corrected quickly. It also means the machine changes more often. A user may shut down one version of the system at night and start a slightly different one the next morning. The start menu may change. A driver may be replaced. A security policy may become stricter. A feature may appear gradually because Microsoft is controlling its rollout remotely. This continuous development model depends heavily on telemetry and staged deployment. Microsoft does not necessarily send an update to every compatible computer at exactly the same moment. The company releases it in waves. It observes reliability signals. If failures appear on a particular hardware combination, the rollout can be paused. That process probably prevented the Intel issue from reaching more devices, but it cannot guarantee that nobody becomes affected. Someone must be in the first wave. This is the trade-off modern Windows users rarely see. Rapid updates can close security holes quickly. Rapid updates can also introduce regressions quickly. Slow updates provide more testing time. Slow updates leave vulnerabilities open longer. Microsoft is trying to balance two different types of risk: the risk that an attacker exploits an unpatched computer, and the risk that the patch itself disrupts the computer. The July update demonstrated that Microsoft does not always get that balance right on the first attempt. The emergency fix demonstrated that the servicing system can respond quickly when the mistake becomes clear. Both statements can be true. The update backfired on certain systems, and Microsoft corrected the identified problem within 4 days. The first thing every Windows 11 user should understand is that this issue does not apply equally to every computer. KB 51201767 was released for Windows 11 versions 24H2 and 25H2. It was specifically designed to address affected devices using an Intel Innovation Platform Framework driver. Microsoft highlighted a limited number of devices and specifically referred to some Dell computers that had been blocked from receiving the original July security update. If your computer runs Windows 11, 23H2, it received a different July update. If it runs Windows 11 26H1, it also belongs to a different servicing branch. You should not assume that every performance problem on every version of Windows is caused by KB 5.01650. To check your Windows version, open Settings. Select System, open About, look under Windows Specifications. You can also press the Windows key and R, type WinVer, then press Enter. A window will display the version, an operating system build. Windows 11 24H2, affected by the original July update, would show build 26100.875. Windows 11 25H2 would show build 26200.875. After installing the emergency update, those builds moved to 26100.894 and 26200.894. Next, open Settings and select Windows Update. Check Update History. Look for KB5101765 or KB51211767. If KB51211767 is being offered automatically, that is the simplest path. Microsoft said, users who enabled Get the latest updates as soon as they're available would receive the out-of-band update automatically. Users without that option enabled could open Windows Update and select Download and Install when the patch was offered. The key phrase is when it is offered. Do not panic because your computer does not immediately display KB5.1767. Microsoft described it as targeted toward affected systems. Your device may not contain the problematic hardware and driver combination. It may have received an updated compatibility rule. It may belong to another Windows version. Or Microsoft may have already integrated the correction into a later cumulative update by the time you watch this video. If your laptop is running normally, do not begin disabling Intel services simply because you heard that the framework was involved. Do not install an unofficial driver package from a random website. Do not edit power management registry values based on one comment under a video. And do not uninstall security updates without understanding the protection you're removing. Start with the official update. Then check the support page for your exact laptop model. Manufacturers often distribute customized chipset, thermal management, and BIOS updates. A generic Intel package may not contain the same configuration as the driver approved for your machine. For laptops, the manufacturer's support application or website is often the safest source. If the computer became unstable immediately after KB51650 and KB51211767 is not available, document the symptoms. Record the Windows build. Check whether the issue occurs on battery, charger power, or both. Restart the computer rather than only closing the lid. A full restart can clear temporary driver and service states that survive ordinary sleep. Check for optional driver and firmware updates from the computer manufacturer. Windows also allows an update to be removed through update history, but uninstalling a security update should be treated as a temporary recovery step, not the ideal permanent solution. Removing it may restore the earlier behavior while also removing July's security corrections. The better outcome is to reach the fixed build. Business administrators face a different decision. They should validate the update on representative hardware before deploying it across every device. A company may own hundreds of laptops that look identical, but contain slightly different components due to manufacturing changes. Pilot groups allow IT teams to identify compatibility problems before a broad rollout. Administrators can examine Microsoft's release health information, use deployment rings, and apply safeguard holds, rather than forcing every machine to update simultaneously. This incident is exactly why those controls exist. For ordinary home users, the biggest lesson is not that Windows updates should always be disabled. Permanent update blocking creates a different and often greater danger. Security vulnerabilities do not disappear because a user dislikes Microsoft's update process. Attackers actively study published vulnerabilities and develop methods to target computers that remain unpatched. The smarter approach is controlled updating. Keep backups of important files. Allow Windows to create restore information. Avoid forcing major updates on the first possible minute when the computer is essential for urgent work. Restart after installation. Check the manufacturer's driver and BIOS updates. Watch for unusual battery, fan, or performance behavior. And when Microsoft releases an out-of-band correction specifically for your device, install the corrected package rather than relying on risky, unofficial workarounds. The July failure matters because Windows 11 is entering another important transition. Windows 11. 24H2. Home and Pro editions are approaching the end of their servicing period in October 2026. Microsoft wants users moving toward newer supported versions. At the same time, every update failure weakens trust. Users do not experience Microsoft's internal testing systems. They experience the laptop in front of them. When an update reduces performance or battery life, the explanation that only a limited number of devices were affected provides little comfort to the person holding one of those devices. Microsoft therefore faces a trust problem as much as a technical problem. Windows Update asks users to surrender control because automatic maintenance is supposed to be safer and easier. Every emergency patch reminds users that automation can make mistakes, but the emergency response also shows why the system is difficult to replace. Microsoft detected the pattern, blocked affected devices, worked with the hardware ecosystem, produced a cumulative correction, and released it 4 days after the original security update. The story is not that Windows 11 completely collapsed. The story is that one of its most routine processes exposed the enormous complexity hiding inside every modern laptop. A monthly security update touched a driver responsible for balancing speed, battery life, heat, and noise. The interaction produced unexpected behavior on a limited group of systems. The rollout had to be restricted. An emergency update had to be released, and millions of users were once again reminded that the most dangerous words in computing may be the ones that appear just before shutdown. Updates are underway. For affected users, the fix is KB512 and WOM767. For everyone else, the warning is larger. Windows. Update is no longer only changing Windows. It is negotiating constantly with the processor, firmware, drivers, and manufacturer-specific systems beneath it. Most of the time, that negotiation happens silently. This time, something went wrong, and Microsoft had only 4 days to make it right.